Here we will start talking the first one about the sedimentary rock. As you see, the sedimentary rock can be formed by two ways. First, from eroded sediments. What do we mean by eroded? That means moved by erosion. We said moving the sediments from place to another is the erosion. So the eroded sediments finally will be deposited, the deposition that we talk about. The deposited sediments will be accumulated layer above layer, layer above layer. Finally, what will happen over the years, they will be cemented by the normal factors in the nature, and they will make a rock such as this. Okay, here as you see the small rock fragments, it means the sediments, they will be transported by wind, water, ice, or gravity, the factors that that help in the erosion. Then they will be deposited. Finally, they will be formed as a sedimentary rock, or by the precipitation from a solution. What does that mean? For example, the halite that is formed beside the sea or beside the ocean. From what it comes? From what? From after the evaporation of the sea's water, what will be left? The sodium chloride salt. Sodium chloride salt will make over the years, it will make the halite that forms the sea rock. The sea rock, such as this. Where is it? Or the rock salt. This, the first one. As you see here to the right, the upper one. So how it is formed? It is formed after the evaporation of the water of the ocean or of the sea, salt water, like this. Finally, here are some shapes or some examples of sedimentary rocks. Here also they show us one of the sedimentary rocks that include inside it shells and remainings of some sea creatures, as you see. So, as what we mentioned at the beginning of this lesson, that the rocks can include in the composition of them some organic material. That's it. This is about the sedimentary. Now let's talk about the igneous rocks. We said that the igneous rock is formed from the molten rocks when they cool. Molten rock can be magma if it was under the ground, or lava if it comes above the ground. So the cooling can take place slowly or fastly. If it was under the ground, deep under the ground, cooling needs more time, right? If it was above the ground, it will happen quickly, because after the eruption finishes, it directly, by the contact with the air, the lava will cool quicker than if it was inside the earth under the ground. This will make a difference in the formation of the igneous rock itself. When it cools quickly above the ground, as you see here, we will have smaller grains. The grains will be smaller. The fragments that will shape the igneous rock will be smaller. Small crystals, but if it cools slowly under the ground as in the granite from magma, the grains or the fragments will be bigger as in the granite. So you can depend on this chart that I prepared for you. We call the igneous rock, if it was formed from slow cooling, intrusive igneous rocks. Intrusive igneous rock that are formed, the igneous rocks that are formed from cooling magma. Cooling magma takes place slowly. So it will form large crystals or large grains. Example, granite. The other type is extrusive igneous rocks. Extrusive igneous rocks formed from cooling lava. Fast cooling, they result in small crystals. Example, basalt or obsidian. Basalt or obsidian. Okay, here also this figure shows the difference between the two kinds of igneous rock. What are the classes of the what is the third class here? The metamorphic rock. The metamorphic rock can be formed by many ways, but the most familiar ways are the high temperature and pressure. The most familiar causes are the temperature and the pressure, the high temperature and pressure, or in other words, the heat and the pressure. The heat and the pressure also very, very deep in the layers of the earth. Where let's talk about here this area that they write above it the word heat. As you see, how many layers above it? You see how many layers of rocks? These layers of rocks make weight above this layer. This weight causes a pressure that will squeeze the rocks that exist in this layer. Beside the heat will make the rock softer, so it can be shaped by the pressure easily. That's it. So both factors, the temperature and the pressure, together they help in shaping, in squeezing and pressing the rock and shaping it in different shape. Let's look at this. This is an igneous rock to the left. This is an igneous rock. Because it was buried under the ground deeply, over the years, the pressure and the heat, they cause this rock to be in this shape to the right. This is metamorphic rock. So we can say that the four causes are temperature, pressure, temperature and pressure together, or fluids or other chemicals. Fluids or other chemicals here, they refer to chemical reactions, changes in the composition of the rock itself. As what we said, rocks are made of minerals. Minerals are made from elements, if you remember, elements or compounds. So these are compounds or elements that can be involved in chemical reactions. So fluids that include some salts, some minerals, can react with the elements or the compounds that make up the rocks and change their composition. It changed their identity. So this is another way. They will talk about it in the next lesson in more details, but I prefer to refer to it in this lesson because mostly we will skip the next lesson to can go to the next unit because most of the information, most of the important information about the rocks are in this lesson, which is more than enough for us about the 3 types of rocks. Okay, so just we will study it like this. It can be the temperature alone or pressure alone or temperature with pressure together or fluids or other chemicals. We can say chemical reactions. Chemical reactions. The most important one is the third. Always we say what can form the metamorphic rocks, heat and temperature. Here also they show us in this figure, this is a mixture of grains in a structure. Let's say sedimentary rock. Here it was sedimentary rock. We said what is sedimentary rock? Sediments that were cemented together to make a rock. Here to the left, this is sedimentary rock. Over the years, because of heat and pressure, the grains were squeezed, as you see. More heat, more pressure over the years, as you see how they become very, very squeezed and pressed in this way. So the shape changed completely. Like the marble, you know the marble, how it has squeezed layers inside it. Most of us know the marble. The marble comes from metamorphic rock. So that's it. This is about the 3 classes of the rocks. Here also some examples about the metamorphic rock. The gneiss is very famous one. This is to the left. Now we will start in the rock cycle. Actually, just I will give you the main concept, then we will continue inshallah in the next lesson. In the rock cycle, we will see that every rock of the rocks, every type of the rocks can be changed to another type. In other words, the igneous can be changed to be sedimentary or metamorphic. The metamorphic can be changed to sedimentary or igneous. The sedimentary can be changed to metamorphic or igneous, and so on. How? We will memorize only the concepts. How? Before going through the details in the next period, just memorize for me this, that any type of rock, any type, you can put here any of them. You can put igneous, you can put metamorphic, you can put sedimentary. After melting, then cooling, it will be igneous. After weathering, then erosion, it will be sedimentary. After heat and pressure, deep under the ground, it will be metamorphic. So this is our concept. This is the principle that we will work on, or we will depend on. That's it. This is the principle of the rock cycle, which will we continue in the next period.